Thought electricity is the fuel of the future? If so, think again. Jeep CEO just dropped a bombshell that has sent shockwaves through the automotive industry with their brand new, mightily fuel-efficient compressed air engine coming in hot to vanquish EVs in their own game. We've got a lot to unpack, so why not dive in? The claim to fame of Jeep's all-new revolutionary compressed air engine is its unmatched efficiency. We're talking about an unprecedented combined EPA rating of 120 miles per gallon and the complete elimination of over 99% of tailpipe emissions. To put things into perspective, the average new car sold in the US in 2023 had a combined rating of just 25.4 miles per gallon, which means a single tank of gas in a Jeep with this all-new engine could take you further than 4 tanks in any other gas-powered car. Not only does this translate to significant cost savings at the gas station, but more importantly, a drastic reduction in your overall carbon footprint. Now, some might be quick to point out that electric vehicles are the ultimate solution for clean transportation and the way of the future. However, Jeep's CEO argues otherwise, going on to state that compressed air technology offers several key advantages over EVs. First, there's the massive issue of the EV charging infrastructure. While EV charging stations are becoming more common day by day, they still aren't as commonplace as the good old gas stations. With Jeep's new engine, you can refill your compressed air tank just as quickly and easily as filling up with gas. Not only that, but concerns still exist about the environmental impact of battery production for EVs, like the mining of lithium and cobalt, which raises ethical and environmental concerns. Compressed air, on the other hand, is a readily available and virtually limitless resource. Jeep's new compressed air engine also presents several performance benefits over Elon Musk's favorite form of transportation as well. Unlike EVs, which can experience a significant drop in range in cold weather, compressed air engines are far less likely to be affected by temperature fluctuations. Additionally, refueling a compressed air tank is significantly faster than charging an EV battery, which can take hours depending on the charging station and battery capacity, making Jeep's technology ideal for those who need the flexibility and range anxiety-free driving that a traditional gas-powered car offers, but with a significantly reduced environmental impact. Of course, some challenges remain, as you might expect. First and foremost, there's no denying that this technology is still under development, and the long-term durability and efficiency of these engines in real-world situations need to be proven no matter what Jeep's CEO might have you believe. Not only that, but the infrastructure for refilling compressed air tanks would need to be established nationwide. If Jeep can successfully overcome these hurdles, its compressed air engine could be a game-changer for the automotive industry, just like they promised, offering a cleaner and more efficient alternative not only to traditional internal combustion engines, but electric vehicles as well. With this being Jeep, this technology could also have significant impact on off-road driving, a core part of the legendary American brand's identity. Compressed air engines inherently offer impressive torque, which will come in clutch for navigating challenging terrain. Additionally, the elimination of tailpipe emissions would be a major benefit for off-road enthusiasts concerned about the environmental impact of their misbehaviors. If Jeep plays its cards right, a silent, zero-emission Jeep conquering off-road trails could be a reality in the not-so-distant future. Now that you have a clear understanding of how big of a game-changer this engine might be, let's take a moment to explore its history. The name compressed air engine might ring a bell in the minds of some of you, and that's for good reason. This engine has a history that runs back over 2 centuries. In fact, the concept of this engine predates the internal combustion engine that revolutionized transportation in the late 19th century. Pioneering figures like Englishman Robert Hooke and Frenchman Denis Papin experimented with early compressed air engine designs in the 17th century, but these early compressed air engines were often cumbersome and inefficient. However, they laid the groundwork for future advancements, like Jeep's creation, which we are talking about today. Although many notable advancements were made in the early days, the limitations of compressed air technology at the time, particularly the weight and inefficiency of air storage, prevented it from seriously competing with the burgeoning internal combustion engine for mainstream transportation. Throughout the 20th century, compressed air engines continued to be developed and refined, finding applications in niche markets like torpedoes, buses, and even some experimental automobiles. But the dawn and dominance of gasoline-powered vehicles kept compressed air on the fringes. However, the latter half of the 20th century saw a growing focus on environmental concerns, leading to renewed interest in alternative propulsion technologies such as EVs and compressed air, which has brought this long-forgotten technology back to the mainstream. mainstream. Jeep's new engine represents the culmination of these past efforts. Advancements in material science have allowed for the creation of lighter and more durable air tanks, with innovative designs for pistons and heat exchangers improving engine efficiency by the day. These developments hold the promise of making compressed air a viable and attractive option for everyday drivers. However, Jeep is not the first mainstream car maker to tango with a compressed air engine. Before Stellantis brought this engine to the mainstream, an automaker from France was the first to experiment with this technology. And as some of you might have already guessed, we are talking about Citroën. Back in the 1950s, Citroën dabbled in compressed air as a power source, not for the engine itself, but for the car's suspension system in the iconic Citroën DS. This innovative system used high-pressure air to create a smooth and comfortable ride, showcasing the potential for compressed air for automotive applications. Fast forward to the late 2000s and the Peugeot-Citroën partnership, which would later go on to become now Stellantis, decided to take a bolder step in the direction of compressed air technology. They unveiled their hybrid air system, a hybrid powertrain that combined a compressed air engine with a traditional gasoline engine. When it was released, the world had seen nothing like it, and the system was designed to capture energy during braking and store it as compressed air, utilizing it for low-speed driving. The hybrid air system promised significant fuel economy improvements, especially when zipping around city streets. While the concept was certainly impressive, the hybrid air engine faced some hurdles early on. The complexity of the system added weight and cost to the vehicle, and the compressed air-only range was also limited, causing the gasoline engine to constantly kick in for longer journeys. Despite these challenges, Peugeot's hybrid air acted as a valuable proving ground for compressed air technology to prove itself in the 21st century, paving the way for Jeep to take the wheel in 2024. The environmental benefits of compressed air technology extend far beyond mere tailpipe emissions. Starting off, the production of compressed air engines is generally less resource-intensive and harmful to Mother Nature compared to electric vehicles, which rely on critical materials like lithium and cobalt for their batteries, and extraction of these exotic materials often has horror stories behind the curtain. While compressed air storage solutions require significant infrastructure development on their own, the materials involved are more commonly available and cause far less of a long-term environmental concern compared to their electrical counterparts. So in addition to emissions, what are the other trump cards Jeep's compressed air engine holds over EV technology? Beyond the convenience of almost instant refueling and the environmental benefits of eliminating the resource-intensive battery production process, compressed air offers several more advantages that are sure to get you hooked. One key differentiator between EVs and compressed air engines lies in the sheer simplicity of the technology. Unlike EVs with their complex battery management systems and questionable charging infrastructure, compressed air engines are relatively mechanical in their operation. In return, this translates to lower maintenance costs and greater repairability, a win-win for Jeep owners of the future. Additionally, the use of tried and tested materials in engine construction streamlines the manufacturing process, compared to EVs that rely on specialized battery components and million-dollar robots to get them made. In addition to all this, compressed air technology has the potential to be more scalable across different vehicle types. While Jeep currently only has plans to integrate this engine on passenger SUVs, don't forget that it is just a brand under the massive Stellantis umbrella. The concept could see major success in larger commercial vehicles like trucks under the Ram brand. The ability to integrate the efficiency of compressed air technology into existing heavy-duty platforms could have a significant impact on the environment. I mean, just look at what Tesla's doing with their electric semi. While concerns exist about the energy efficiency of compressing and storing air, Jeep CEO assures us that they are working on advancements in material science and thermal management systems. The development of lighter and more durable air tanks, combined with innovative heat exchangers that capture waste heat from the Jeep's internal combustion engine for improved efficiency, could significantly address these limitations. Additionally, research into utilizing renewable energy sources like solar or wind power for air compression holds promise for creating a truly sustainable transportation solution. However, it's important to acknowledge that compressed air technology still has a long way to go. The energy density of compressed air is still lower than gasoline or EV batteries, which translates to a shorter range for compressed air vehicles. While this could be a deal breaker for some, don't forget that Jeep's new innovation is still in its infancy. Do you remember how the range on EVs sucked when they were first introduced? Jeep is onto a winner with the compressed air engine, and if the claims of 100 miles per gallon plus fuel economy and practically zero zero emissions are to be believed, it would be only a matter of time before the whole world ditches EVs and embraces compressed air technology as the next big thing in transportation. The war against EVs has already begun, and we have multiple videos on our channel covering their downfall. Why not like, subscribe, and check them out?